So over here we see that I put in the first connector, and from right to left it's supposed to be the negative electrode of the laser, and then you have your earth, then you have your AC, and I think the order doesn't matter, that is not specified in the schematic. So just gonna turn it on, and as you see, the fan powers on, the LED lights up, so everything is pretty standard, it's pretty working at this case. The only issue now is the laser doesn't seem to want to fire. So over here, I have actually soldered on the wire onto the little prong that sticks out, and the same is done on this side. And alright, let's just see what happens. Let's just show what happens first. So I'm just going to put the camera over here, and I'll just press the button. Maybe I'll move this arm away so just so you can see what actually goes on. There's a small button over at this point over here. There's the test button, and I'm just gonna press it and see that basically nothing happens to the laser. Well, I'm just gonna turn everything off. Okay, and I'm just going to test to check that the connections over here and over here on the other end of the laser tube, which is over here, are actually connected. So we're just going to do a very simple multimeter check. To do that, I'm going to take out this high voltage connector over here, and over here we see that it exposed this tiny pin, and I'm just going to switch my multimeter. Just put it over here so everyone can see it. I'll just switch it over to the continuity mode, and just to show that everything's working fine, if I were to put these two leads together, we see that the value should drop to about 0. Yeah, it drops to about 0. A bit of rubbing, sometimes a bit of dirt on it. Or let's say if I put both on this plate of aluminum, we see the value drops to 0. So let's just go ahead and test the connection on this anode, this electrode over here. So I'm just going to put one of this inside this to touch the pin, and I'm going to put the other one right on top this carbon rod. And we see that, okay, this is connected, but the carbon rod doesn't seem to be connected. Oh, there we go. We have to scratch out a bit of the flux, but we see that alright, maybe the flux is adding some resistance. There we go, about 0. It's small resistance due to the flux on the carbon. Maybe you can try another angle like this. Well, either ways, don't think there's any other way. There we go, about 0. Yeah, I don't think there's any other way to attach this. Oops. Yeah, maybe no, I don't think there's any other way to attach this wire onto this laser tube, just using this method. And I've actually removed, or I should have added I should have added a shrink wrap, but that probably won't be necessary given the fact that one of these components are going to have to change. So once again, just going to put these two back in, and now I'm going to test the other side, which is the negative electrode. And once again, I'm going to show everyone that there really isn't any connection problem, or at least connection problem that would lead to failure. There's something's really going on with this. Okay, I'll just leave it aside here. This laser tube. So once again, I'm going to put the multimeter here like this, and I'm going to test that it's going to say 0 when we put these together. There we go. So I'm just going to remove this shrink wrap over here, just to make sure that it's turned off. And this laser has never fired before, so there's probably going to be any charge in the capacitors. Well, in either ways, I'm just going to put one of the leads on top of this, like so, and the other lead I'm just going to go straight and put it on the bottom where it attaches to the attaches to the power supply. So we see it, okay, there's a bit of resistance due to flux. Or if I go to the side like this, alright, so I'm going to just check to see if there's any issue with the button. Perhaps the test button is not, perhaps the test button is faulty. So how this works is that on the other pins of the laser cutter, laser power supply, we have a signal or an enable pin, which when put low will basically fire the laser. And we have also a PWM input or analog input pin that will basically take PWM signals or potential physical analog values, voltage values from a potentiometer that we can use, that you can use to control the intensity of the laser beam. In this case, we're just going to check that when we press the button, the laser enable pin is put to low, because if that's the case, then we know that there's not some issue with the button and that there's some issue with the power or the actual positive anode connection or the transformer that's used to create the very high voltage for our laser cutter. So once again, I'm just going to power this up. Be careful not to touch the right side because that's where all the live current is. Okay, so I've got it powered up, and I'm just going to put my multimeter somewhere here. I'm going to change it to voltage setting. 20 volts is enough because it should only read about 5 volts at the max. And I'm going to put my one lead onto ground over here, and the other lead I'm going to put it on the live, or not the live, the signal wire. And we see that the voltage goes up to 4 volts, so that's when it's high because it's a pull up. If we pull this down by pressing the button, so we need to check if the button does pull the voltage down to 0. So I'm just going to press the button with my index finger of my right hand over here. I'm just going to press the button.
So although we did get a voltage on the pins when we pressed the button, it was below the 0.3 turn on voltage that was required for this laser power supply to work. Unfortunately, I did also try to ground the laser enable pin to bring it to 0 volts, but that didn't work as well. However, I wasn't able to record it, so perhaps in the second follow-up video I will be showing you how that turned out as well. But in this case, pressing the button clearly does not power on the laser, and that therefore it seems that there is some issue with the internal circuitry of this board, and that's preventing it from operating. All in all, we've seen that there is some issue with laser power supply in the sense that it is not able to power the laser. We've tried to eliminate possible sources of error such as the connection with the laser tube, as well as also tried to troubleshoot with the pins, and we found that there was some issue with respect to the voltage that the pin shows. So we're definitely going to give this as feedback to our manufacturer, and hopefully they will do something about it. On a personal level, this is quite frustrating as I've already spent about a month on this project. I was hoping to be able to finish it up and push it out before the end of the holidays, but given this current turn of events, I think I'll have to be able to wait a few more months before it's finally pushed out. Yeah, overall this experience has been pretty good, to be fair. Everything, the entire design from the fusion to the implementation has been pretty good, going well so far. And just a bit, yeah, it's just a pity that this laser power supply had to hold things up. Hopefully we'll be able to get some recourse and we'll be able to move on